In this video, I'm going to talk about defining points using the input bar. In a previous video, I had shown how to create points using the toolbar tools, but now I'm going to use the input bar to define points. So in general, if we want to define a point using the input bar, we can name the point. So maybe we name it A, and then use an equal sign, and then parentheses like in mathematics, and then you give the x and y coordinates. So maybe we'll do 1, 2. So A equals 1, 2 is going to create a point at 1, 2. And this looks pretty similar to what it would look like mathematically. So we'll hit enter, and it's going to create a point A at the location 1, 2. Now when we define a point in this way, the point is actually free, meaning that you have full control to move this point around the screen. So we'll move it around, and as we move it, the coordinates of this point are updated over in the algebra view. So there's nothing fixing this point to that location by default. Notice also that there's this lingering point at the original location. This seems to be a bug of the GeoGebra web version. If you go to the input bar and just hit enter with nothing in there, it'll make that point disappear. So that's just something to be aware of. If you ever have a lingering object, just go to the input bar and hit enter. Now, once we've defined this point A, we can actually use A in subsequent commands to create new points using A, or even new objects using A. So for example, we could define another point named B that is equal to A, but now we're going to add 2 to the x coordinate and 1 to the y coordinate. So A plus 2, 1 will be the new definition of B. Notice that the point B is black by default, meaning that this point is dependent and we can't actually drag B around the screen. This is because it's dependent upon A, but as A moves, as you drag A around, B will update accordingly. Let's look at 2 more commands that will create points in slightly different ways. So first I'm going to create a circle. I'm just going to name it circle, and we'll use a circle function, and don't worry about the details of this, I'll cover it in a different video. We're just going to create a circle around the point A, and now we're going to create a third point. We're going to name it C. We'll say C is equal to point. There's a function called point, and the tooltip tells us that, hey, give me an object, and I'll create a point relative to that object. So let's feed this point function an input of circle. If I hit enter, it's going to create this point C, but now C is constrained to the circle itself. This is a pretty useful thing. C is still somewhat free in the sense that we can drag it, but it's constrained to the circle that we defined it on. In a similar way, we can create a point named D and use a function called point in. And if we give it the circle object again, as you could probably guess, it's going to create D so that D is constrained to live inside of this circle. So if we move A, all these points are going to move relative to that, but they're still constrained to their respective regions. GeoGebra also has a few predefined objects that you can use without actually having to define them yourself. So for example, I'm going to create a point, I'm going to name it XP, and I'm going to use the point command, and I'm going to feed an input of X axis. So X, capital A, XIS. And this XAXIS, X axis, is a predefined object, and it's literally just the X axis of the graphics view. So if I hit enter here, it's going to create this point XP, and it's constrained to live on the x-axis. In a similar way, we could do yp equals point, y-axis, and we have this point that lives on the y-axis. So those are 2 predefined objects that you can use, and it's sometimes useful when you're using that point function. Now, one last thing in this video, GeoGebra also gives you access to the corner points of the graphics view. Now, what I mean by that is, I'm going to define a point. I'm going to do C subscript 1, or C1, and I'm going to use a function called corner, and it gives us a hint. Okay, we could use the number of the corner, So let's feed that number 1. This is essentially saying, let's define the first corner point of the graphics view. So I'll hit enter, and it's not going to look like anything happened. We don't see anything additional in this screen. So what I'm going to do is actually create a segment. I'm going to name it S sub 1, and I'm going to use a segment command, which I'll cover in a later video, but we'll create a segment that starts at C sub 1, and then we'll take that segment to the origin. So essentially what the segment is doing is starting at C1, or the first corner point, and then going up to the origin. Now if we drag or we pan our graphics view around, notice that that corner point is fixed exactly in the corner of the graphics view. And this is what the corner function does. It gives you the points that will always live at the corners of your graphics view, no matter if you pan your graphics around.